And we're live. Okay. Advent of code, day 2. Let's check it out. Let's open up the. Am I in there still? Cool. 2. Here's our problem. Day 2, rock, paper, scissors. The elves decide to set up camp on the beach. There we go. And drag them down a little bit. Oh, shit. There we go. The elves are playing rock, paper, scissors. Oh god. I know what rock, paper, scissors is. Okay. It's a game between 2 players. Many rounds. Yup, yup, yup. Encrypted strategy guide. Puzzle input. Be sure to help you win. The first column is what the opponent is going to play. A, B, C. Rock, paper, scissors. Second column. Okay. The second column, you reason, must be what you should play in response. X, Y, Z, rock, paper, scissors. Winning every time would be suspicious, so the responses must have been chosen carefully. The winner of the whole tournament is the player with the highest score. Your total scores is the sum of your scores for each round. Shocker. The score for a single round is the score for the shape you selected. 1 for rock, 2 for... Okay, so it's not just the win. Is that right? The shape and the outcome. So you get bonus points for winning with scissors. Okay. Plus, since you can't be sure, you should calculate the score you'd get if you were to follow this strategy guide. For example, suppose you're given a Y, B, X, Z, Z. This strategy guide predicts and recommends, so that would be rock versus paper, uh, paper versus rock, so win, loss, and tie, scissor versus scissor. Rock score of 8, 2 because you chose paper, and 6 because you won. So if I just played scissors every time, I would get 3 points every. Like, why not just spam scissors? In the second round, your opponent will choose paper. Third round is a draw, both choosing scissors, giving you a score of 6. You'd have a total of 15. Okay. Give me the input. Command A, Command C. Let's make a new directory. Day 2. Touch day 2 slash input.txt. CD day 2 touch strategy RPS strategy .py. Okay. In our input.text, I'm going to paste the input we got. Yeah, I still haven't looked at the Visual Studio Code thing. It's a little goofy right now. That's okay. My extensions aren't quite there. So there's no new lines. Every line has a round. Every round has 2 inputs. I play, you play. Let's make a little dictionary to go ahead and, since we know there's a part 2 to this challenge, I'm going to start out writing it in a function. Define, let's call this calc total score. No input. Let me go ahead and outside the scope of this function, that's where we'll define our relationship between A, B, C, X, Y, Z, rock, paper, scissors, and the score. Okay, what's the cleanest way to define that to not confuse me? So A is rock. So let's say, what should I call this? This is like the key, but a key is it's actually like a hyper abstract term. So let's say it's a legend, even less. Let's say it's the point. I don't know. Whatever, it's the point map. We'll change it. It's bad, sorry. So on the one hand, we have the key. If we're reading this file, we're gonna ultimately have an input of opponent and let's say opponent choice, my choice equals whatever read. We'll break up that line dot split across the space, right? With open. This didn't work last time, but I believe day 2 input.text as f for line in read f dot read lines. Okay. So this will be opponent is a set of either A, B, or C. My is a set of either X, Y, or Z. Z. So we've got a few translations to make. We have one, the translation of A or X to rock, and two, the translation of rock to the score. Right? We need the translation to rock to determine a winner. Or do we? I don't think we do. I think we could just stuff it in there. But let's say we need the translation of rock to determine a winner, and we need the translation to the points to determine the score. So let's say scores. Key. And the key here will be rock, paper, and scissors. Rock is worth what? 1? 1. Paper worth 2. Scissors worth 3. Opponent key. Let's spell out opponent. So A maps on to rock. Good lord. Why are you upset? Oh, okay, my bad. B maps on to paper. And C maps on to scissors. Okay. And this will be my key. Okay. my key. And this will be X, Y, Z. All right. And we're really just totaling. We don't need to do, I guess we do need to do a comparison between rock, paper, and scissors, right? So we need to define that relationship somewhere. Um, you'd think I would have made a rock, paper, scissors game being a coder. That's like one of the most basic, like intro, like, hey, you learn how to code, let's play rock, paper, scissors. But I don't think I ever did. I think I did tic-tac-toe. Um, how would I define this efficiently? Can I use another hash map? We're already 3 hash maps deep. Like, it's kind of a lot. Um, so we could say if we could use a map and say we could associate the key with what was played and the value with what it beats. But that doesn't work because we have 3 options. It could be a draw as well. I could just change some if statements and not think about it. Um, we could say is there a trick here? Like, what if they? Oh no, because that doesn't work. Scissors. So rock beats scissors. Uh, paper beats rock. This might be a good trick, right? So if we get paper, look at the index before. That's the one it beats, right? Look at the index before. In Python, it loops around. That's the one it beats. Look at the index before. That's the one it beats. Right? So if I look at scores key dot keys, that should let me iterate through there. We could maybe force it into a list. And just check the indices, see who wins. That's interesting. Let's see if that works. Um, Asserting that index minus 1 of keys array equals victory. That's entirely unclear. Asserting that the choice, whatever, bro, nobody's gonna, let me just write it and then maybe I'll explain it, okay? So, let's say encoded. Opponent encoded, my encoded equals line.split. Opponent, is that two underscores there? Wilden. Opponent decoded, let's just call it choice, equals opponent key dot get opponent encoded. Or none. It should never be none. My choice equals my key dot get my encoded or none. Oh, sorry, I've been writing in JavaScript. Okay. Rock, paper, or scissors. Say, valid choices equals list, scores key dot keys. This is just me being lazy. I could just type it out again, but I do want to check real quick that that this is actually what I think it is. So valid choices should contain rock, paper, and scissors. Hopefully it didn't leave an error or anything down there. Good lord, what's happening? Dict keys. Yeah, okay, good. This is why we check, folks. Okay. What if I change this? Keys dot. I just want the keys. From keys? No. Items? No. Values? No. Set like object. Let me try using the list function instead of the angle brackets. See if that helps. Oop, you can stop. Oi. Okay. Okay. There's a lot going on there. But we're looking at what we wanted to be looking at. Alright, cool. Map code to RPS string. Map RPS string to score. So now the weird little logic thing I mentioned before is that the list is ordered. In this case, rock, then paper, then scissors. Rock at index 0, paper at index 1, scissors at index 2. Paper beats rock. 1 minus 1 is 0. So if my answer is paper, I can look to see whether the index in this valid choices list of my opponents is my index minus 1. And if it is, then I know I won. If it's mine plus 1, then I know I lost. And if it's the same as mine, then I know it's a draw. Okay? Makes sense, right? You could actually also do it with the scores, right? 2 minus 1, 3 minus. So maybe that was even a hint. But we're going to use the indices because that was my bright idea. Okay? Okay. Maybe I'll make a little inner function here. I won't actually because I know performance doesn't matter. Def determine score. Opponent mine. Op choice my choice. As a string, we be type hinting. Oh, that's JavaScript moment. As stir So valid choices dot index of my choice. Good lord. Store that in a variable. My index. That's a bad name, but opponent index. Right? If my index, do I only have to calculate my score? My total score. Okay. If my index minus opponent index, if the difference is 0, return 0, right? Draw. Oh no, draw gives 3. We're gonna write this and comment it out. Outcomes key. Draw 3. Win 6. Lose 0. That's right. Isn't it? Isn't it? Isn't it? What does it even say? The outcome 0, 3, 6. Okay. I don't think I actually need that, but it's good to keep in mind. Okay. If my index minus opponent index is 0, return 3. So it would be a draw. If my index minus opponent index equals 1. Wait. Oh, let's make it a little less weird. Okay. If my index equals opponent index, if my index greater than opponent index, meaning I am ahead of you. So let's say the opponent chooses rock, I choose scissors. No, it has to be a difference of exactly 1. My index minus 1 equals opponent index. Scissors minus 1, paper, paper minus 1, rock, rock minus 1, scissors. Ugh, but here's the problem. I think I need to do a list lookup on the index instead of getting the index before, because the scissors is 3, or 2, it's the second, it's the third. The index is 2, it's the third entry in the list. So what's going to be stored in here is 2. But another way to refer to that is a -1. In Python, you loop around. So I forget what it's called. But I'm just going to store my index. And then we'll do the opponent index lookup on the fly. All right. So we'll say if valid choices dot index of not dot index, valid choice at my index -1, equals opponent choice. Yeah, this is starting to make sense now, right? So of all the choices, we're going one before, right? So scissors to paper, paper to rock, rock to scissors. If we look at that index and we find that it matches the opponent's choice, then we know we won. If we look at that index, +1 is always a loss. Rock loses to paper, paper loses to scissors, scissors loses to rock, rock loses to paper. Then we know that's a 0. And otherwise return 3. Right? Let's pretend that that's correct for now. Score, my score equals determine score. Op choice equals op choice. My choice equals my choice. We love the keyword arguments. Prevents any oopsies about which one goes in first. Okay. And we're just calculating the total. So let's create a variable in here. Total score equals 0. To determine okay, so we can so the problem I just noticed was that I'm only determining the outcome score here, right? So we'll say plus scores key of my choice. So this will return, if it's rock, it'll add 1 on there. Ugh, I can just tell in the second one they're gonna be like, okay, now also calculate your opponent's score and see if anybody wins. And this isn't gonna work too well for that. But we'll cross that bridge when we absolutely have to. Okay. I want to only do this plus scores key once. So score equals return score plus scores key. My choice. Let's can I change the name of this? Outcome score. Okay. If that, then this. Otherwise that, else that. So only one of those will ever be chosen. And it's always going to add the value of my choice on there. All right. I could do this on one line. Right? I don't care. I do care, but I don't care. Say I don't care. Really, I do care. So this, okay, now I just what is it called? Increment? Total score plus equals my score. There's no time where we need to reset. And at the end, we're just gonna return total score. All right, let's see how this goes. Main. Aw, y'all hear that train? It's popping off. Determine, calculate, calc total score. Let's print it. All right, save and run. First time's the charm. Oh gosh, okay. My B, I forgot you decided to pretend like that was all one word for some reason. Okay, so let's see what's going on here. So the new line is ruining things. Let's strip it first. See if that helps. Z, C, cool. Yeah, we should just be able to let that run on through. Oh, problem. List index out of range. So that would occur. That would occur because I chose scissors. Okay, yeah, okay, that is a bug. All right, let's address that. So let's just move the draw into the else so that I don't have to worry about that. Because -1 is a valid index, but 4 is not a valid index. So when draw, lose. Okay. So in this case, my index equals opponent choice. Let's try that. Give me a number. All right. Without any further consideration, let me actually just quickly check each score and make sure it's like kind of reasonable. So my score is 3 on a game where I chose scissors. That doesn't seem right. Let's add a breakpoint in here. My choice rock. Outcome score 6. And oh, my score, total score. My choice rock. So rock and I won. That adds up. I chose scissors, and the outcome score is 6, so my final score should be 9. Okay, looks like it's adding up. I don't know, that first one was a little sus. Did I just read it wrong? Like, I don't know. Let's find out, eh? One thing about VS Code is when I run the debugger, the terminal goes absolutely wonky. Oh! Okay. Please wait 1 minute before trying again. Okay. So what did I do wrong? My score was too high. Two because you chose paper and six because you won. One. A draw with both players choosing scissors. Am I doing that right? Oh, yeah, there's literally just a bug here, or a typo. So a draw should give me 3. But it says my score was too high. So on each of these, let's say print print my choice. Hold on. My choice beats opponent choice. Okay, hated that. Draws. Loses too. Okay. Scissors draws scissors. Rock beats scissors, scissors beats paper, rock draws rock, scissors loses to rock. Scissors draws scissors, paper beats rock. So let me make sure my scores are correct. Rock, paper, scissors. Draw 3, win 6, lose 0. I wonder if this 6-5-1-8-5 was not actually my outcome. Let's find out. Get rid of this. 1-5. That is lower. Maybe because I was adding 3 for every. No, but I never was. I should my. Where did that 6-5 number even come from, eh? Well, now we'll never know. Okay, let's try again. Oh. So logic was sound. Okay. How long did that take me? 40 minutes. Oh, okay. Okay. Anyway, the second column says how the round needs to end. X means you need to lose. Y. Oh, okay. Tricky. Okay, thank God I don't have to do the math for the opponent's score. You would get a score of 12. Oh, in their example. So in the first round, the opponent will choose rock, and you will end in a draw. Okay, so I think my little index thing will still come in handy. Because we are already determining what the, pardon me, what the outcome will be. So, new function. I don't really need a new function. This is like 90% the same, but for calc total score again, but different. This is very professional. PEP8 code, so don't at me. Okay. So now inside the determined score, Let me read this one more time. You need to figure out what shape to choose. So now the part that really changes is this is now the outcome, right? So I can reuse my determine score function. I just need an additional function, def determine choice given outcome, right? And this needs to follow a similar la da 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 structure. Also, let me la da da da. All right, so if I mean actually, so I do need an outcomes key now, but it doesn't look like this. That will be the value, right? Oh, sorry about that. My apologies. What I'm trying to do is just not that either. There we go. I hate that for me, honestly. Let's try it this way. Okay. Still didn't work. That's okay. Not everything is efficient, Ethan. Chill. So what's the key? Y is draw. Y is draw. X is lose. Z means win. Okay. My outcome. Opponent choice remains the same. My choice is now going to be determine choice. Oh, sorry, buddy. Sorry about that. I thought you were the other guy. My bad, my bad. Da, 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 da. Outcome. My choice now going to equal determine choice from outcome. Now we just need to fix this up here. Fix it on up such that this actually returns the outcome. Alright. So let's say if outcome key outcome equals draw return. Oh, I'm also going to need the opponent's choice. Also stir. Give him to it. Give it to him. Give it. Okay. No. Oh, choice. Okay. If we want the outcome to be a draw, then we need to return the valid choices array at the very same index. Oh wait, this needs to be opponent index. opponent index equals valid choices dot index opponent choice. Okay. Something smells good. I'm hungry. I didn't eat dinner. I'm gonna need a snack. Okay. Return the same one. And I think this strategy still works with the draw. elif. Oh, that is the draw. So you go on down there. And we cool kids up here. Get down there. We cool kids up here. We'll say if outcomes key. Honestly, bro, let's just do that whole key thing once up here. Let's do it before we even pass it in. Outcome encoded. Outcome equals outcomes key. Get outcome encoded. Okay, so now we're passing outcome. We already know it's rock, paper, scissors. Oh, didn't mean to do that. Trying to delete the line. Oh, okay. I guess I also deleted the line. I'm getting confused here now. Alright, that's fine. This is me not documenting code. Maybe I'll document it after before I upload. Because there's a lot happening here. So here, let's document it now. I need to get back on track, alright? Read encoded values. Decode as outcome and opponent choice. Select proper choice given outcome. Calculate score for a round. And then that line doesn't need a comment. Okay. So we just need to make the determine choice, determine choice function work. And we also probably also need to, oh no, we kept him in here. He's doing good. We've got the index equals win. If outcome equals draw, the whole key thing is outdated. What are you, oh, cause I don't have anything in this body. If it's a win, if the outcome is a win, remind me. Win means I would have the one directly above it. Right? So I would have the opponent's index plus 1, which is a problem because if my opponent chooses scissors, I'm going to get an index out of bounds error. So we can't do that. Oh, let's do the lose. Let's do lose, draw, win. Sorry, wrong. Wrong one. Outcome is lose. Lose. Return valid choices. Op index -1. Alright, because that means if the opponent chose scissors, I will return paper. If the opponent chooses rock, I will return scissors. Perfect, perfect, perfect. Else, Um, hmm. Oh dear. How do I calculate the winner? We would add one, but that's going to give us index out of bounds. There's a weird noise happening. I don't know if you can hear it. It's really distracting, actually. Um, I could always just add a if statement in here to normalize it to where if it's out of range, but I feel like there's got to be a more elegant solution. Maybe there's not. If it's a win, I'll just do that. If op index equals 2, return valid choices of 0. Else, return valid choices op index plus 1. Because 2 is the only problem child, because 3's out of range, 1's fine, 0's fine. And this should just reset to 0. Ew, grody, icky, stinky, extra if else statement. If you know a better way to do this, please inform me. Okay. Let it work. It should work, right? Let's add some print statements in here. Print op choice outcome S draws wins lose. And then whatever we've got in here. Why though? Oh, why? My goodness, my goodness, my goodness. Op choice outcomes that. Ooh. Sorry. Okay. We still have the score. We're still giving it the choices. We're still incrementing. So let's throw a breakpoint in here. And you know what the but different. Okay. And we're going to debug it. Scissors wins rock. That is giving me an incorrect vibe. Does scissors wins rock? Does it? Okay, but in this case, my choice is rock. Oh wait, that's irrelevant. Outcome is win. Opponent choice is scissors. So I should choose rock. Yes. I should just switch up. So just as to not confuse myself. in all of these, I need to move the order around a bit, okay? Okay. Don't mind me. Just doing as I do. Okay. Draw. Win, lose. This with that. Okay, let's see how that looks. Okay, let's see if it makes a little more sense. Win scissors with rock. Amen. Preach, brother, preach. Lose scissors with paper. Facts. Win paper with scissors. Factual. Lose rock with scissors. Let's go till we see a draw. Cool. Cool. Okay, that's adding up to me. Remove the breakpoint. Let it run through. 16098. Is that correct? Dun, 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 dun. Woo! We did it. Okay. All right. Excelente. Uh, we solved it. Let's go ahead and push it up to GitHub there. With these all commented out, because we don't want any poor souls who run this code to just be printed out 1,000 lines of text. Okay. I feel like it would be kind of fun to save the prompts for this. Can I do that? Give me prompt. Okay. Let's throw that into day one. New file. Prompt. I assume he wrote that in Markdown. Let's see. We'll see if it might just be text. Let's be honest. Let's be honest. Let's change it to Markdown. Move day one slash prompt to prompt dot today day one prompt dot txt. Okay. Day two, please. This is day one. Oh, I see that I have not actually renamed it. I thought the move command did a renaming, but I guess not. Okay. Alright, git status, git commit dash a dash m, day 2 complete, added prompt to repo. Actually, I think that, so I want to save this, but I'm pretty sure if I do dash a, it's not going to add the new files. So git add, and then we'll do this. Okay, git push. Oh, okay. I probably just added the readme. Update readme in remote merge. Let's make sure it doesn't look wacky. I need to tweet it. All right. Uh, there we go. Mm, 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 mm. This is called marketing yourself, okay? You gotta be a little cringe. What do we want to say here? Day 2 of Advent of Code complete. This one was a bit trickier, but thanks to some handy dictionary lookups, I was able to come to a fairly straightforward, comprehensible solution. Recommend this challenge to anybody who enjoys puzzles, even if not a programmer. It seems like a lot like you can come to a solution with a tool like Excel or Google Sheets. Without it wouldn't be a stretch to arrive at Python, learning in public, interview, prep. Algorithms. All right. Thanks, folks. Good times. Good times. Just a quick hour to solve probably what's equivalent to Elite Code Easy. But let's just real quick, let's compare myself to people who are better than me so that I feel less accomplished. Let's check out the leaderboard. How long did it take the fastest person? Okay, so the way this leaderboard works is I think it opens at midnight in my time. So honestly, I could stay up another hour and do another puzzle if I wanted to. I don't. I'm tired. Uh, Leaderboard. Took the first guy 350 what? Or is that how many points he got? Oh, it's the total score. But I want to know how fast it took him to solve it. Can you not see that? Come on, Oliver. Tell me how long it took. Python. Let's see what his solution looked like. Gosh, what are you? Is it Rust? Oh, Python and Rust. I see. Okay. Let's see what his day 2 looked like. Interesting. So this to me looks like a guy who's done a lot of these kinds of problems. Because I don't even know. That's him defining my hash map here. This outcomes and this opponent key dot index. That's a trick I'm going to keep in mind though. That's pretty cool. I'm glad I'm looking at this. Using a match statement. This is his whole solution? Bro, you're wildin'. You're wildin' right now. Split the line, get the answer. Mod 3. That would have made things a lot easier instead of me using the -1. You know, bro, I'm keeping an eye on you, brother. You're fast as hell, dude. Going wild. Alright, that's cool. What'd you do on day one? Huh? One-liner. Max sum int for I and split for x in read dot split. New line, new line. Don't ask me why. Don't ask me why.